Am I audible now? Am I audible? Okay. Okay, so my voice is clear, right? There is no problem with the voice. Okay, thank you so much. Yeah, so what I was saying, hashing we are studying. Okay, there are searching time of some data structure. After that, there are few, yes, there are few data structures which we are discussing. Here I have written a note where hashing time decreases. So we have to compromise either with time complexity or with space complexity. But here we have chosen to do the compromise with space because time is very important, right? So after that, these are all the things which you should remember because directly 1 mark question can come from this. So that was very, very important. Now let's see the next one. Okay, so till the time you note, let me check if there is any problem. Yes. Now let's write a note for this. If we use hashing, then on average it will always be theta of 1 time. Okay, if we use hashing, it will be on average theta of 1 time. Now let's talk about direct address table. Direct address table. So direct address table. So this is a basic concept is to put key, okay, key in a plus key. What this means that whatever is the key that we have to put that into a table. So let's say we have 23 and here are some table sequence which is 1 2 3. So in which block this 23 key will get inserted? So this is direct address table. All right, now some limitations are there, and what are the limitations? Let's see. For this, limitation is that if say list is equals to the size of list is 1 0 0 0 0 0 6 is there, okay, and after that 1 0 0 0 0 0. So these are the key, okay, these are the key, and just two keys are there. But how much space we are going to make for this? These many space. So let's say I have just two keys, 1 lakh and 1. So for these two keys, I have to make the space of 1 lakh. Okay, and the 1 will go inserted into first place and the 1 lakh key will go inserted into 1 lakh place. So that is the drawback. Just we have two keys, but still the space is requiring 1 lakh. So this is the major drawback of this direct address table. Okay, I am writing note also here that 1 million space required for just two keys, and this is the major drawback. This is the major drawback. So the next note is only use when range is small. When the range is small, just like 1 2 3, then you can use this. But if it is in millions, thousands, it is not preferable. Okay, so here comes now hashing. The concept of hashing comes from here. Hashing. Now let's say we have a key which is ki. So some hash function we will use. For this hash function I am defining h of k. So this is the hash function h of k which is defining. After that, this is the data structure. and data structure will be in like this, DS, data structure. So this is what it will get select, like which data structure we are using. And let's say the space is from 0 till M. Okay, and what will be the formula? So h of k will be k mod m, k mod m, like in which position or in which space it will go. But here in hashing we will also face collision problem. Let's say here is the table, 20 and 30 are the keys and 0 is the block. So the collision will happen. If we take modulo of 10, so what it will give? 0 for 20, 0 for 30. So here it will collide. That which will go first? 20 will go first or 30 will go first, right? So this is the problem known as collision problem. Let's see. So collision problem. Collision problem is what? When two or more keys map onto the same place, that is h of ki equals to h of kj, then collision happens. Okay, and what is the solution for this collision? There are 3 solutions. Okay, so this is the problem. Now let's discuss the solution for this. So solution is, the very first solution for the collision problem is better hash function. We want a better hash function. This is the first solution. Second solution is that chaining. Okay, so good for key detection. No, not key detection, it is key deletion. Like here detection doesn't happen, insertion, search and deletion happens. Okay, so good for key deletion. Third is open addressing. So open addressing, so this is bad for deletion. Okay, and in open addressing we have several things. The first is linear probing. Probing means attempt. Okay, linear probing. Second is quadratic probing. And third is double hashing. Okay, so these are the 3 types of open addressing. Now let's discuss what is a load factor. So one of the direct question came from here, load factor, just by the formula. So if you know the formula, you can easily solve the question in GATE. Load factor. So what is the formula of load factor? So load factor is alpha. It looks like alpha, okay? Alpha equals to n by m, and here n is number of elements, m is size of table. Okay, now let's see the key factors for chaining. So chaining, the very first is insertion. Okay, so insertion, search, deletion. Insertion, search and deletion. So insertion will take theta of 1, search will take theta of n, deletion will take theta of n. And here the average search is theta of 1 plus alpha. Okay, now here the point which you should note is deletion is easy in chaining. Is easy in chaining. Deletion is easy in chaining. And pointers required here. In chaining, pointers required. So pointers I have written. Pointers required, which means we want more space. Now let's discuss linear probing. Same. Linear probing. So hash function h is k of 1, 2 till n, k of n, where 0, 1, 2 till m minus 1, let's say we have the function. So here h k of I is equals to h of k of plus I mod m. Okay, and the probe sequence will be, let's say, h of k of 0 column h of k of 1 column h of k of 2 and so on. So what will be the sequence? Yeah, and this suffers from linear probing, suffers from primary clustering, secondary clustering. Okay, it suffers from primary clustering and secondary clustering. Okay, now let's see quadratic probing. Till then, I hope there is no doubt in this. Now let's discuss quadratic probing. So quadratic probing is h of k, this is k, plus c1 I, c2 I square, mod m. This is the formula. And depending on the values of c of 1, c of 2 and m, okay, which is success of quadratic probing. Success of quadratic probing can be judged. Alright, and number of probe sequence possible is m, since that depends on the initial value of m. Okay everyone, now let's discuss double hashing. Double hashing. So in double hashing, number of probe sequence possible is what? Equals to m square. Okay, and does not suffer from both primary and secondary clustering. Okay, which is h of k equals to h of k plus I h2 k mod m. Alright, now let's discuss what is secondary clustering. What is secondary clustering? So secondary clustering is, see, if two keys happen to have same essential space or props, which is called as attempts, okay, then the rest of the attempts, the technical term is probe, okay, sequence will be same. So K1, right, 1, 3, 7, so on, this will be like this, 1 to 3, 3 to 7, 7 to so on. This is K2, which is 1 to 3, 1 to 7, so on, like this. Alright everyone? Now this was all about hashing. It's time to discuss for trees now, okay? So let's revise trees. Tree. The very first is binary tree. Binary tree, okay? Each node having at most 2 children. Each node having at most 2 children, right? Second is full binary tree. Full binary tree, which is all levels are full. All levels are full. Third is complete binary tree. Complete binary tree, which means all levels are full except possibly the last level, which is left as possible, right? Now K-array tree, have you heard about K-array tree? And anything in this, if you didn't get, so you can ask. Okay. Now let's discuss K-array tree. And these are points, and this is the revision class. If you feel like I am not discussing anything in detail, so I will be not. Why? Because this is a revision class, and already which you have studied, that only I am revising. Okay. So K-array tree, internal node having k children. Internal node having k children. Okay. All levels need not be filled in K-array tree. So let's understand one important relation in K-array tree. Important relation in K-array tree, which is what? I plus L equals to IK plus 1. And this 1 is root. Let's discuss what is I, what is K, what is L. Okay. K is degree of internal node. I is number of internal node. L is number of leaf node. So this L is nothing but I k minus 1 plus 1. Like this. Now let's discuss the relationship between leaf node, internal node in binary tree. Relation between leaf node and internal node in binary tree. So n1 is internal nodes with one child. Okay, n2 is internal nodes with two children. And what will be the relationship here? It will be 2n2 plus 1 n1 plus 1, which is equals to n1 plus n2 plus 1. This will be n2 plus 1. This is n2 plus L. Okay, and n2 plus 1 is equals to L. And this is valid for any binary tree. This is valid for any binary tree. Let's discuss now some basic formulas of this. Basic formulas. N equals to number of nodes. Okay. B equals to branch factor. H equals to height. D equals to depth. B2 is equals to B equals to 2. That means this is binary tree. B equals to 2 means this is a binary tree. So this is for just example. Let's discuss about complete binary tree. First is for complete binary tree. Complete binary tree, which is 2 of h smaller than equals to n smaller than equals to 2h plus 1 minus 1. Like this. Okay. Now if we take log on both sides, so it will be log 2 of h log n log 2h plus 1 minus 1. Okay, and h equals to big O of log n. Big O of log n is for complete binary tree. This is for full binary tree and also for balanced binary tree. Everything it will work. And otherwise, I am writing here, otherwise it also will be big O of n. Otherwise it will be big O of n. Now let's see for full binary tree. Second, for full binary tree. For full binary tree, n equals to 2h minus 1 plus 1. Okay. Third is sum of height of all nodes is bounded by big O of n, where r minimum is equals to log 2 of n and h height maximum is n minus 1. Now let's see rank of node. Okay. Rank of node. So it is defined as so rank of I equals to number of nodes in left subtree plus 1. Okay, so this is the simple concept. Now let's discuss array representation for tree. The topic is array representation, array representation. The very first is root, which will be 1. Left subtree will be 2i. Parent, which will be floor of I by 2. Right tree will be 2i plus 1. Okay. Max array size, which is 2 to the power n minus 1. So this is not complete, or which is we can say as full. Okay. And this is 2 ceiling log base n minus 1, like this, minus 1. So this is full, or we can say that this is complete. Alright everyone. Now let's discuss number of binary tree possible with n nodes. Okay, with or without label 1. Number of trees binary possible with n nodes. So first is for unlabeled nodes, which is 1, n plus 1, 2nn, which is cn. Okay. For labeled, which is 1 by n plus 1, 2nn. So this is 2cn into n factorial, which is cn into n factorial, like this. Now let's discuss about tree traversal. Point is tree traversals. So tree traversal, first is in order, left, root, right. So let me take one example. In that I will tell. So this is A, this is B, this is C, like this. So in order traversal, what are we going to consider here? BAC, like this. Second is pre-order, which is root left right, and that will be ABC according to the example, if you can see. Then the third is post order, which is left right root, and this is BCA, like this. Okay, like this. And some shortcut also I will tell for this, how to write immediately this all things. So one note just keep for this. So this is I, let's say this is tree, this is tree, this is I, this is one tree, this is the another tree, this is I, let's say this is one tree, this is another tree. Now just see here, whenever you are searching for in order, just see here, and for pre-order here, and post order here. See how you can do dots here, like this. So dot here, dot here, dot here. This is for in order. So what will be the sequence if you will come? B, A, C, like this. And this is for in order. Now pre-order, what I said, just keep the dot here, 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 here. If you will go here, so it will be A, B and C, like this it will move. And for post order, how are we going to keep the dots? This side, this side, this side. This is how. So B, C, A, like this. So this is a very, very good shortcut which you can apply in the exam. And this is how I've written. Here I will note that this is in order, this is pre-order, This is post order. And what is the time complexity? So Tc is the time complexity, which is T of n equals to big O of n. Okay, like this. Now let's see double order and triple order. Double order, so which is do T if T print T, do T left print T, do T of R, like this. This is the diagram. So this is the another tree. In order and pre-order. Now let's write for, so this is for double order. Let's write for triple order. Triple order. So for triple order it is TO of T if T print T, to T L print T, to T of R print T. Okay, and for triple order I am drawing the diagram, so which you can see here. So this is diagram for triple order. Okay, so I 1 2 3 and here like this. So this is for pre-order, post-order, in order. Okay, now let's learn about binary search tree. Binary search tree. Let's discuss this binary search tree. So for every node, the keys in left subtree are less than the keys of current and the right subtree. Nodes are greater. Okay, and in BST, in order always gives sorted order. In order always gives us sorted order. One node for number of binary trees possible. So one direct formula is there for this. Number of binary tree possible, which is 1 by n plus 1, 2n n. So this is also 2n cn combination, you all know. Okay, if structure is given, only one BST is possible. So insertion if skewed Tn, so big O of n. Okay, and this is the worst case. If balanced, so T of n, which is big O of h, and this also we can write it as theta of log n. Okay everyone, now let's discuss deletion. So deletion, first case when no child is there. No child is there, then simply we can remove. Okay, just remove. But what if the child is there? So normally we can have two childs. Let's discuss about one child is there. Then we have to delete the node. We have to delete the node and make connection with grandparent. Okay, we have to make connection with grandparent of the disconnected node, But what if we have two child? So there is also a process for this. Third is two child. So when binary tree, we are talking about binary tree. Deletion case, no child, one child and two child. Okay. So there are two methods for this, for two child. The first is replace with in order. So here we will first take out what is successor and predecessor. As per that we have to replace. So replace with in order, and that will be with successor. Second is replace with in order predecessor. So either you can do. Okay, so successor also is fine and predecessor also is fine. But if we will do with in order successor, so what are we going to get the result? In order successor. In this we are going to get minimum element in right subtree. Okay, so minimum element in right subtree when we go with in order successor. But if we go with in order predecessor, so this time we will get the greatest element in left subtree. Okay, greatest element in left subtree. Alright everyone, do you all have any doubt in this? Any doubt till now? Okay, so let's move ahead. Now let's discuss about AVL tree. Okay, AVL tree. AVL tree is very important because in GATE, like almost all the year the questions has been asked for AVL tree. And the questions are not so tough, like 1 to 2 marks. It depends on the question. So if it is difficult and you have to shift the complete tree or make it balanced, then 2 mark question ask. If is there like you have to see the sequence, then 1 mark question also you can get. So what is AVL tree? It is for height balanced. It is height balanced binary search tree. Height balanced binary search tree. And one key point here is the height between the internal node and the leaf node will always be -1. It can be -1, it can be 0, it can be 1. So only these differences are acceptable. If you say the difference is 2, it is not acceptable. Then you have to rotate. Okay. So this is also called as balance factor. Balance factor. So balance factor means you have to the height of left tree subtract it with height of right tree. Okay, and single rotation you have to do. Let's take one example on this so that you all can understand. So let's say this is 30, this is 20, this is 10, this is 10. And see in GATE how the questions can be asked. See, this is given and the options are given. Option A, this AVL tree is given. Option B, this AVL tree is given. Option C and option D, some AVL trees are given. And you have to select either which of these are correct. Okay. So if it is not balanced, you have to make it balance and check. So this is, let's define. So here here 10 will have the height 0. Alright. 20 will have the height 1. 30 will have the height 2. Here 20 is, let's say this is y. 30 is, let's say this is x. Now what is the difference between 30 to 10? It is 0 minus 2, right? And minus 2 is not at all acceptable. So I am writing here not satisfy. Because the height difference always should be minus 1, 0 and 1. Then only it is acceptable. Okay. So we will do left rotation. And this is a single rotation. Okay. Single rotation. Now if we do the rotation, so in the middle 20 will come. Here it will be 10 and this will be 30. The height of this is 0. The height of this is 0. Okay. And left minus right height, the height of this also will be 0. So now this is fine. Okay. Completely fine. Let's see the second example for this. This is 30. This is 40. And let's say this is 80. Now the height difference here is, this is 2. This is minus 1. This is minus 2. Again, this is not acceptable. So here we are going to do right rotation. So the rotation will look like this. Right rotation. And this is also a single rotation. Okay. Single rotation. So this is 40. This is 30 and this is 80. So this is how the rotation will look like. These were the examples for single rotation. Let's discuss now double rotation. Okay. So for double rotation, I'll take this tree 30, 20 and this is 25. So this is 0, this is minus 1, this is 2. Okay. Now here again the difference is 2. We have to do the rotation. Now here, see, here this is L and this is R and this is L. So this is L, R. So LR rotation or RL rotation we have to do. And this is a double rotation. Double rotation. Which is like this, like this. Now, see, here we will keep 25. Here 20 will be there. Here 30 will be there. Let's say this is X, this is Z, this is Y. So it will be Z, Y, X. Like this. Like this it will be. Okay. Now let's discuss few points on this. After inserting an element, we travel from newly inserted node towards root and verify if any node is imbalanced. Okay, but if there is an imbalanced node, then what are we going to do? If imbalance is there, then go from imbalanced node to newly inserted node. Okay, that we can understand what type of imbalance occurs, and that's how we will just change it. we can change it. Okay, now let's see some operations on AVL tree. And basically what are the operations? Insertion, deletion, or construction of n elements. So operations on AVL tree. Operation on AVL tree. So the very first operation is insertion, let's say deletion of one element. So if you know the deletion operation, insertion operation for one element, and let's say in exam they gives for n elements, so simply you have to multiply n. If one element deletion insertion is log n, so what will be for n? It will be n log n, right? So these are simple things. So you have to understand, you just have to remember the basic things. After that you can just change it that in exam. So big O of log n. Now if we have to construction with n elements, let's see this. Construction with n elements, which is big O of n log n. Yeah, this is the example which I was talking about. We have discussed about one element. What if n element comes? So here simply just multiply it with n. So that will be n log n. Okay. Now let's discuss minimum, min and max node in AVL tree. Topic is min, max nodes in AVL tree. AVL tree. So height will be given h. Okay, let n of h equals to max node in AVL with height, okay, which with h height. So it will be n of h equals to 2 n of h minus 1 plus 1, which is 2h plus 1 minus 1. Okay, and s of h equals to minimum nodes in AVL height of h. Height of h. Height of h. So how it will be? The equation. See, it will be s of h equals to s of h minus 1 plus s of h minus 2 plus 1. So s of 0 is 1, s of 1 is 2, s of 2 is 3. Okay. Now let's see some nested notation. The concept is nested notation, and after that we will see stacks and queues. Nested notation. The notation is like this. 1, 2, 3. Okay, 1, 2. Let's say this is 5, 2, 3, 4, 6, 7. So that will be root, left subtree, right subtree, 1. Left subtree will be 2, 3, 4. Right subtree will be 5, 6, 7. Like this. Okay. I hope there is no doubt till here. No doubts, everyone? With in order and out order. Aman, can you tell me what are you talking about? With in order and out order, which one? Are you there, Aman? Clear? So John is saying clear. Okay. So Aman, you can ask me again if you have any doubt. I will clear it out. Okay. Let's move ahead, everyone. Now let's discuss stacks and queues. So with that, let's get started with stacks and queue. Stacks and queue. So the first is stack. So the first point here is it is a linear data structure. DS means data structure. Second is it is following first in, first out, last in, last out. Okay, first in, last out, not last in, last out, first in, last out. So two notations it follows. All right, and yes, so second is ordered list. It gives us ordered list, insertion and deletion done at one end. And which is that end? It is the top end. So in stack, insertion and deletion both are done from top. This is the property, and always we get a ordered list. Okay, let's discuss the applications of stack now. Applications. The very first application is stack permutation. Second is infix to prefix conversion. Third is infix to postfix conversion. Fourth is expression tree. Fifth is recursion. These all are the applications of stack. Let's understand what is stack permutation. Okay. Stack permutation. Stack permutation means push elements in given order. After that, pop elements in any order. Any order we can do it at any time. So what is the number of stack permutation? So if n is there, what n denotes? A, B, C. So here n denotes 3. So it depends upon the nodes. Okay, n denotes number of nodes. I'm writing here total number of stack permutation. Total number of stack permutation equals to 1 upon n plus 1 2n n. This is 2ncn, which is the combination. Permutation and combination you all know. So this is the concept where it relates to. Let's talk about now recursion. And after that, I will give you a short trick for this. So recursion. So you have to understand some terminologies, which is T of n, which is number of function calls for f of n, right? S of n, which is max depth of runtime stack. Okay, so tail recursion means that recursion at last statement. So what is tail recursion? See, if the code is there and at the end of the code if the recursion happens, that is called as tail recursion. Okay, so opposite to this is head recursion. RE I am denoting it to recursion. Okay, so REC is also recursion like this. Recursion at first statement. So at the very first statement if recursion happening, it is head recursion. And what is head tail recursion? Mix of both. Yes, very good. Mix of both. Which is recursion both at last and first or last, anything you can consider. Now let's discuss a function which is a x y, which is y plus 1, here x equals to 0, a of x minus 1 y, y equals to 0, a of x minus 1, a of x y minus 1 otherwise. This is for the else case, and this is called as nested recursion. Recursion in recursion is called as nested recursion. So I'm writing here nested recursion. Right? Now let me give you some short trick for this. So short trick is, so if you see the question, directly you can solve by this short trick, and that too in less time. You will just see the screen and you will get the answer by this short trick. So please remember, a of 0 of y, which is y plus 1, a of 1y, this is y plus 2, a of 2y, which is 2y plus 3, a of 3y, this is 2 to the power y plus 3 minus 3. So this is the short trick which you remember. Let's discuss about Tower of Hanoi. So let's have some little discussion. Although the questions are asked less, but we are doing the revision, so let's revise it completely. Any doubt till now? Everyone? Okay, so let's discuss Tower of Hanoi. Tower of Hanoi. So it is denoted as T of H. The parameter it takes is N, L, M, R, like this. If N minus 1 is there, left to right happens, else we will call it again T of H, N minus 1, L, R, M. Okay, this is for last two, which is third, fourth, we have to swap. This is the symbol of swap for the last case. This R and M, and this will be L to R. After that, T of H, N minus 1, M, L, R. So in this case we have to swap the second and third, and the function is completed. Again, I am saying I am not discussing the things in detail because this is a revision class. You all know the concept very well. Just the formula I am discussing here. Okay? Otherwise, if you will say why I am not explaining all this in detail, so this is not that class. This is the class for complete revision. So all the short notes I am discussing here for every single topic. Number of function call, 2 of n minus 1. After how many function call first move occurs, which is n. Okay, after how many function call largest disk placed, so it is n plus 1. Okay, now let's see infix, postfix and prefix. And the last is all the time complexity table. I will attach that in the description, which you can see. Okay, right now I cannot draw this, so simply we will move on to the C programming part. All right, after this. So infix, postfix, prefix. Infix is what? Operator in between operands. Infix is what? When operator in between operands, which is a plus b. Like this it is denoted. Okay. postfix is operator between operator after operands. Okay, operator after operands, so which is AB plus. And what is prefix? This is operator before operands, operator before operands, which is plus AB. So this is the example. So from this I have denoted like this. Now the part left is time complexity, array, unsorted array, sorted array, stack, queue, linked list, hash table, BST, AVL tree. So all this I will just attach this in the description below, because it is a long table, so which is not possible for us to discuss here. So simply you can read that. Alright. Now let's see the short notes of C programming. I hope this class was very helpful. See, for the C programming, why it is important? Because in GATE always 8 to 12 marks question comes. Okay, now we are discussing programming language C. Okay, and every time 8 to 12 marks question comes. So let's discuss now some memory registers. So what are the memory register? So here the table is other, code, text, region, data region, stack region, and this is heap. Okay, like this it is. So this is other, like this it is. It is like this. So this region is static variable, and this region is for global variable. This is for explicit memory management, which is malloc, calloc types function. Stack region, this is for local variable, stack, frame, and parameters. Okay, now let's discuss about static memory and dynamic memory. Alright. Static memory. The first is code region. This is for the system. And this is for data region. So this is program. Dynamic memory. So this is for stack region, which is system. Okay, and here we will have heap, which is program. Alright, any doubt in this? Are you all getting things? Very good. Now let's move ahead, everyone. Let's see C language processing, how the processing happens. Let's see that. C. Language processing. C. Language processing. So first what happens is C code is there. After that some preprocessors are there. Okay. After that compiler is there. Then assembler is there. And then what is the step? Linker or loader is there. Okay. And between preprocessor and compiler, preprocess code happens. After that assembly code is there. Okay. And this is the executable code. This is the executable code. This is linker. This is linker. Okay. Linker resolves external files and variables. Loader performs relocation, performs reallocation. It performs reallocation. Okay. It does the allocation and deallocation. And this loader always there in main memory. This is always there in main memory. Let's discuss now memory formats. So little Indian and big Indian, Indian or Indian, whatever you can call it. So I call it Indian. Okay. Memory format. Memory format. First is little Indian, which is first least significant bit. First is least significant bit, then is most significant bit, which is how it will look like. See, 0 0 0 0 0 0 1 0 0 0 0 0 and after that 0 0 0 0. It is like this. Then reverse order. Reverse order. And the second is big Endian. First most significant bit, then least significant bit, which is last. So this is 0 0 0 0 0 0 0 0 0 0 1 0, like this. Okay, so this again all will be 0 and this is 0 0 1 0, like this it will be. Okay, forward order. Forward order. Forward order. Any doubt here in this? Okay, let's see ahead. Now language. In language, code is there, data is there, and in data, instruction is there, static management is there, programs are there, languages are there. So let's see this. So let's discuss code. There is instruction, state managements, okay, After that, programs are there, and then language is there. So how it will go? From language to program? Set of programs. Okay. After that, programs to here. This is group of instruction. Group of instructions. Like this. And now data. So for data, final representation of something that cannot be converted to any other form. Now let's discuss the stages. Okay. So the very first is characters are there. After that, tokens are there. Then syntax. After that, semantic. And this is the logic. So the logic may be correct or may not be correct or wrong. Alright, may not be correct. So here basically compilation happens in this step. Compile. Okay everyone. So what are tokens? Let's discuss that. Token means first is group of C character. Second is it is the basic smallest unit of logical program. Okay, grouped by using longest prefix rule, which is minimal also we can see. Let's discuss types of tokens. What are the different types of tokens? So the very first type is keywords. So keywords there are so many keywords. Int, float, char. Okay, int, float, char, short, long, signed, extreme, if, do, while, for, break, etc. Let's so reverse words. Second is operations. So what are the operations? Arithmetic, logical, bitwise, relational. So these all are the operations and so on. Identifier. So the very first rule in identifier is should not begin with digit. So this is the rule. Fourth is constants, which is also called as literals. Okay. Fifth is special symbols. Okay. So one note you should remember here in this, x equals to y, this is L value, this is R value, and it can be anything. So see, R value can be anything. R value can be anything, but L value cannot be constant. It cannot be constant. And array name. So array name also it cannot be. Now let's discuss some precedence. Okay, some precedence rules. So you can just Google it out for the precedence table. You can easily get and just remember that. So notice, yeah, and also just remember right associative and left associative, because if you will give several operations where plus, minus and bitwise operator are there, then you should identify and should solve the problem. Okay, so you can just Google it out the table. It's there present, and just remember for the operation. Now let's see what is printf and scanf. So printf means which returns characters printed, and scanf means it returns the arguments pass. Okay. Now the very important is storage classifiers. So in storage classifiers we have memory region, lifetime, scope, initial value, declaration, definition, local variable or global variable. Okay. So let's see the table for that. Storage classification. Storage classification. So the first is classes, auto, register, static, extreme or extern, not extreme, it is extern. Now here memory region, lifetime, scope, initial value, declaration, that you should know. So this is stack. This is so memory region for auto, stack. This is stack slash register. Okay, and this register might be given or may not be given. And here static is data, extreme is data. So here is block, lifetime is block, here is block, here is program execution, and here all program. Scope is there, this will be block, here also will be block, this is block program, all program. Initial value, this will be garbage value, 0 and 0. Declaration will be 1, this will be 1, and this will be greater than 1, this is also greater than 1. After that, number of definition is left, local and global is left. So definition is 1 for auto, 1 for register, greater than 1, and local global, this will be local, this will be local, this will be local slash global, and this will be global as well. Any doubts? No doubts. Now let's see control structure. So in control structure, the first thing we will see is for loop. Control structure. For loop. S1, so for S2, S3, S4, S5, S6. So how control structure will look like for this? So I am drawing. This is S1, this is S2, this is S3. Okay, so if the condition is false, we will go to S6. If the condition is true, we will go to X5, S5. After that, we will go to S4, and again the loop will happen. So like this, the loop will be there. Okay. Now let's discuss switch case. Switch S1, 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 switch E, case C1, S2, this is break, and this break can be optional, right? Case C2, S3, this is break, and like this it will be case Cn, Sn plus 1 and break, like this. And after that default also can be there. So default Sn plus 2 break. Okay. So like this it will be. Simple structure. Any doubts? So the next one will be arrays. Okay everyone, arrays will be there. See, arrays are left. After that, storage is left. Okay, then pointers is left. Pointers in array. Then problems with pointer also we will discuss. What is lost memory, C strings, all type of string. After that we will go to function. So library, user defined, call by value, call by address, everything, parameters, and recursion is very important. Activation record also we will discuss. After that structures and union, then constant scoping, dynamic scope, and every single thing. So one by one we will cover all. So I've taken data structure from the first. Actually some technical issue happened in the last class, so it got recorded just for half an hour, and the extended class I've taken first of data structure, and after that I've started with programming. So if you have any doubt and queries regarding the lecture, you all can ask. So this is the revision class is going on for every subject. We have just completed data structure, the first lecture. After that, we have also discussed C programming. Okay everyone, any doubt till now? And see, for more such valuable content, you just can subscribe. So whenever you will subscribe, you will get the notification for the class and you can join. Okay. So thank you so much everyone for this